from Springfield College in his 6th year, Mr. Will the Thrill Nickerson!
Good. Gold. Hoi hoi, Mr. Nickerson here. And today we're going to cover a little bit of 9-5, factoring the difference of two perfect squares. When we have the factoring of the difference of two perfect squares, we're only going to have two terms. And both terms need to be perfect squares. But in a crucial part, you got to have difference. We got to have subtraction. So we've got x squared minus 81. And some of you may remember, chapter 8, we had shortcuts for certain problems. This would be a shortcut answer problem from chapter 8. So we need to remember that pattern going back here to factor this one. So, x squared minus 81, well, you know there's no b value. So for some people, they like to think of it on the first problem as this and say what numbers multiply to negative 81 but add to 0. We learned how to do this already, so we would know that this would be 9 and negative 9. If we check this out, we know by the shortcut we only have to square the first, square the last, and always have subtraction. So it does check out to our original expression. But instead of having to write 0x in all our problems, we should just know the shortcut that when we have the difference of two perfect squares, subtraction of two perfect squares, that the factoring is always going to be the parenthesis, the square root of your first term, minus the square root of your second, and the square root of your first plus the square root of your second. Does it matter if the plus or the minus goes first? No. Okay, you could put the plus here, you could put the minus there, but that's the general pattern. So let's look at the next examples. Next one, x squared minus 16, two terms. Perfect square, subtraction. We've got all things we're looking for. So we know it's x minus 4, x plus 4 for our answer. And if we check that out by shortcut method, we know it's going to bring us right there. If you're not somebody that liked the shortcut method before, you're going to need to FOIL that out. It's really beneficial on problems when there's a's other than 1 and we got difference of two perfect squares. So we look, 9x squared minus 16. 9x squared is a perfect square. The square root of that, 3x. 16, square root of that, 4. So we've got 3x minus 4, 3x plus 4 for our answer. And then if we check this out, we shortcut back, we're going to see 9x squared minus 16. On the last one, well, we look again, and sure enough, we've got 5x is the square root of 25x squared, 7 is the square root of 49, so we've got 5x minus 7, 5x plus 7. Check it. I'm going to shortcut method it here. We shortcut 25x squared minus 49. If you're not a shortcutter, FOIL that thing out and you'll find those answers. The next problems you'll see. Okay, so let's take a look. Sometimes we see two terms and we don't see the difference of two squares. We always check first for GCF, what we learned the first time we started factoring. What's the GCF of 12 and 48? It's 12. What's left inside? 1 minus 4x squared. And in the past, some of you said, oh, we're finished. No more. Well, there is stuff left you can do. Okay, we got to double check that parenthesis and say, is that now the difference of two perfect squares? Well, 1 minus 4x squared. 1 is a perfect square. We got subtraction, and 4x squared is a perfect square. So the 12 will stay out front. And the square root of 1 is 1. The square root of 4x squared is 2x. So we got a 1 plus 2x and a 1 minus 2x. And we've successfully factored that. Let's keep going. So we look at 54x squared minus 24. We got to find the GCF between 54 and 24. For this one, we're going to see that the largest number that goes into those would be 6. And when you pull the 6 out, you get 9x squared minus 4. Now that you have that, double check inside. Perfect square, subtraction. We've got the difference of two perfect squares. 3x minus 2, 3x plus 2. Final answer. Occasionally, you'll do the problem out, and you'll see what happens is you don't have what you need. But let's see. On this one, 12x squared minus 48, 12. X squared minus 4. Sure enough, another one with the difference of two squares. And finally, 12x squared minus 4. Pull out our GCF. We got 4. 3x squared minus 1. We look at this one and we say, oh, we got x squared, we got a 1, that's a perfect square, we got difference of two squares. We don't this time because the 3 is not a perfect square. So then, can we do anything else with this? No. You gotta always double check. Sometimes you see like this one, obviously, then this one. If you think it's gonna happen on the next, not always. Go ahead, try the last 3 on your own. Okay, now that you had a moment to try those, let's take a look. So on the first one, m squared minus 121, we see right away that we know 121 perfect square, m squared perfect square, we got the difference that we need. So we got m minus 11, m plus 11. Check it out, did my shortcut, it worked out. On the next one, very similar. We look, might have a GCF we think at first, but this time we don't, because 9 we know doesn't go into 64, and 3 does not go into 64. Since it doesn't go in there evenly, we know we can try to see if they're perfect squares. They are perfect squares, and then it checks out. On the last one, we know 3 is not a perfect square, so that jumps out at you to always check for GCF. GCF, pull it out. You do have a GCF of 3. You're left with y squared minus 49z squared. Factor that, difference of two squares, and you have it. That concludes today's lesson. We'll see you tomorrow.